Hi everyone, Professor Stickle here. I just wanted to highlight a few things for your 10th lab for linear algebra. Quick reminder, when you think of what you've done over the last 9 labs, you have gained a lot of facility in using MATLAB in these different ways. You can use it as a basic scientific calculator. You know how to estimate functions now using numeric computation through defining appropriate vectors and matrices. You've done the same kind of thing and done different calculations using symbolic computation. You've practiced your ability to model situations mathematically using a polynomial curve fit given a certain data set or given certain data points. You've created these 2D and 3D figures, and you know how to label them properly, create titles and legends and all of that, and manipulate data in order to visualize things in these different ways. You know how to define a matrix, access and change parts of a matrix through proper indexing, do different matrix calculations and all of those kinds of things, and some of the tools that MATLAB has built in to solve systems using matrices and that kind of sort of approach. And in all of this, you've developed this ability to write simple scripts and to capture and save the different commands and organize your thoughts by organizing your commands one after the other after the other. This idea of algorithmic thinking, or thinking through a problem in a real careful way using MATLAB, really is done through this development of writing simple scripts. And next term, when you take programming, you'll sort of extend that into writing actual functions that are your own. And finally, you have some sense of how to seek help, how to get answers to your questions around MATLAB, or specific syntax or specific ways that you can do certain things using the online help tools, but also just any other online source. So in this last lab, before you actually begin the final project, you're going to learn about conditional statements. And so essentially, conditional statements allows you to create branching within your code, or essentially different roads through which your code can go down. Hugely important component to any programming language, any numeric or symbolic computation approach, essentially. And this is a really simple example. So essentially, if you're looking to set a variable date to a number based on a particular word that's captured in this variable today, then you could go through this process. So if today is equal to Tuesday, let's set it to 3. But if today's Wednesday, let's set it to 4. Otherwise, in all other cases, because I don't care about any other days except for Tuesday and Wednesday, let's set it to 0. So that's a very simple way to say, take in some information, this input variable today, and then create another variable date with certain values depending on what the value of today is. And so in MATLAB, we could use this simple structure, and it based on this if, else, and end. So essentially it is if, but if, or else if, and then otherwise in all other cases, that's the else statement, and then the end wraps it up. So let's see what this looks like in MATLAB. So if we bring this in, essentially I define this variable today, and then I can set the state value based on what value today is. Now, if I were to actually do this in MATLAB, this code actually doesn't work very well. So let's take a look at the way we could actually implement it. If I define my variable today, and so I've just randomly defined variable today with a bunch of words in it, I have to define it as a cell array. And so this cell array is determined or defined by these curly brackets. And it's a new type of variable which we haven't talked about yet in MATLAB, but it's a way to store strings and manipulate strings in MATLAB. So what I want to do, here's today. I want to cycle through every value of today. So I have my index I cycling from the first element of today, which is Sunday, to the last one, which is Saturday. And the length today will return the value 8. So I'll be going from 1 to 8 with a step size of 1. And I'm using this is equal function. So I could also say certain things like, say, 4 is equal to 5. that's a logical 0, because we know that 4 is not equal to 5. But if I did 4 is equal to 4, it'd be a logical 1. That's a true statement, and 1 represents true. So I could use this double equals, but actually it doesn't work when you're using cells. And so there's this other function called isEqual, which essentially does the same thing, but extends this double equal sign to cells. And so as I go through each value of today, Sunday, Monday, Tuesday, Thursday, Wednesday, Sunday, Friday, Saturday, this will check to see, is the ith element, is the first element, the second element, the third element of today equal to Tuesday? If it is, set the date variable to be 3. And you can see that I've used I to also indicate the date. So I'll have a date 1, a date 2, a date 3. And so when I run this, I can see that I have my 1/8 cell variable today, and it's shown here as well. My I is the number that it ends up in, the last number, which is 8. And my date is this vector. And you can see that it's 0, 0, hey, 3, 0, 4, 0, 0, 0. So all the days I don't care about except for Tuesday and Wednesday. And so I've set this and created this date variable based on this set of conditional statements, and my for loop, which allows me to cycle through every element of today. So let's look at another example. So there's different ways of doing branching, and this is one way. So say I wanted to look at a particular plot, and I wanted to find when is a function larger than 0. And so you've seen this kind of thing before already, and I can essentially just use the find command to do this. I could also use if statements. And so if, else, end, if all I care about is the positive values of y, then I can cycle through my values of y. So essentially this index e in this case cycles from 1 to the number of elements I have in x and y. And if y of e is greater than 0, then I set this new variable y positive to store all of the positive values of y. Of course, if it isn't, if it's 0 or less, I just set that new variable to 0. So what do you think my plot would look like? So let's take a look and first do this. So this is my plot, and you can see that the x and y is the blue lines, and the y positive is, or the values that are y positive are the stars. And so you can see it pulls out everything that's positive, but not the 0 values or the negative values. And so the way I did this was I used the find function. This find function returns all the indices of y that are positive. And so then I used the indexing of x and y to only plot the positive values of y using this ypos index. So through careful indexing I can do this. But I could also do this using this other function. And so let's try that now. So if I run this code that does the same thing except using if statements, then the type of thing that I'll see is the same exact figure. Except now you can see that when y is anything except for anything but positive, it just sets it to 0. So that's one of those differences between this other plot that I've made using this other script. So in this case, again, what this produces, you can see this only pulls out the positive values. There's no 0 here, whereas in the second case, when I actually set these values to 0 very specifically, then I can see that in this figure, these are set to 0. So the whole point is that I can manipulate the data I have based on certain conditions that I'd like to see. And the if statements allows me to kind of play around with those conditions and cause my code or certain decisions to be made based on the values that I have in my other variables. Last example I just wanted to share with you is multiple branches. So let's add in an else if statement, as opposed to just saying, if this happens, do this, or all else, do that. That's what we had in this case. So if this happens, do this. Otherwise, in every other case, do this. So if we have multiple branches, we can have, if this happens, plot this, please. If this happens, plot this, please, and also do this. Otherwise, in all other cases, do this. And the nice thing is you can add as many else if statements as you want. So you can have, a very large number of branches based on different conditions. So you could have if, else if, else if, else if, else if, else if, else, and then end. So you can make lots of decisions based on your code. Okay, so let's take a look at what this actually does. So we'll clear everything. And so is this what you would expect from this sort of result? So as I go through, I've defined my sine function using x and y. I plot my sine function, that's what this blue line is here. And then I hold everything, so any new plot is just overwritten or added on top of that blue line. I set my variable count, whatever that is, to 0, and then I cycle through every single value of x and y. I ask myself, is it 0? Double equals indicates exactly equal to 0. If that's the case, plot a red star. So that's exactly what happened here. So this y never reaches 0 again. So right here, it actually doesn't ever have a 0 value. And then right here, it also doesn't have exactly a 0 value. So that's what we do if it's 0. Otherwise, hey, maybe I'm interested in every value of y that's greater or equal to 0.8. So the greater or equal to 0.8, plot a blue plus sign. And so that's what's up here. You can see right up there, that's where I've plotted these values. And I also have counted. So now I can have a count of exactly how many values in this function are above 0.8. And if I check what that is, hey, count is 21. I could also look at my workspace and say, hey, that's pretty cool. There are 21 points that are plotted here that are above 0.8. And otherwise, in every other possible case, plot a black, that's k, dot. And so that's what you can see is these black dots. And then add a grid to it at the end. So maybe let's add, 1,000 elements or 1,001 and run this again and see what happens. So now you can see that, hey, I get a whole lot more blue plus signs, 205 in fact, and the black dots just look like a black line. But when I go zoom in, I'll be able to see these individual black dots, the line behind it, and then the blue plus signs. So this is the amazing thing about conditional statements, is that it really allows you this huge amount of flexibility to make decisions within your code based on the values within your code. So a classic example is if you have some control system that a robot is depending on to make certain decisions, the sensor that it's using recognizes that it's about to go off the end of the stairs, that there's no wall in front of it. It's going to tell that or receive that and then says, okay, I have to turn left or right. And so it can make decisions based on the input variables that it's dealing with. So I hope this gives you a good quick introduction to conditional statements and that it's helpful in lab number 10 as you sort of wrap this lab up and then prepare for the second quiz that you'll have at the end of lab 10 and then get ready to use these ideas, both for loops and conditional statements in your project over the next couple of weeks. Last thing is I always leave with, of course, as you always know, remember, always, always, always critique what you're doing. Ask yourself, does it make sense? Do these results, does this plot, do these numbers actually represent what you would expect MATLAB or the numeric computational tool that you're using to give you?